Well, good afternoon, everybody, or good morning, wherever you are from in the world. On behalf of Abu Dhabi National Oil Company and Tabreed, we welcome everyone to this panel. My name is Alvaro Escorcia. I work in ADNOC Group Technology in a role of technology and innovation. We deal with decarbonization, clean energies, and sustainability technologies primarily, both in the upstream and the downstream sector. I'm privileged to have here on this panel Dr. Rahul Fonseca, who is a senior specialist again on technology and innovation. He's going to share quite a bit of the experiences that we have had with this milestone that we achieved here in the country with the geothermal. We also have Imad Hamlawi, again from the team of technology and innovation in ADNOC. Imad comes a bit more from the drilling background, and Rahul comes more from the subsurface background. But the reality is that at the moment we are all clean energy, new energy, and decarbonization, to be honest with you. We also have Ahmad Jalboot, who has been working fairly close to our team, and actually all his team over the last, I would probably say, year and a half or 1 year to make this happen. So having said that, I just want to run very quickly to what the panelists are going to be covering. We're going to be covering the aspects of harnessing the geothermal. We're going to focus on describing the potential that is being evaluated in the UAE. Then we're going to dive down a bit more into what cooling means within the geothermal, the benefits of the energy, and obviously the technology and innovation that is being used. Then the panelists will dive into describing a bit more the pilot that we're just wrapping up at the moment. And then we're going to talk about turning the challenges that we learn into opportunities going forward. With that, I just want to remind a little bit of where we are. This is where we are. We're here in the United Arab Emirates. By the way, this is the weather from this morning. This is 45 degrees C, which should be way over 120 F or higher than that, north of that maybe. Obviously, we are an ecosystem of a fastly growing economy, both in terms of the industrialization, technology that is being adopted in the country, and really integration with the world. So that's what the UAE is about. So without further ado, I think we should hand over to our first panelist. Dr. Rahul, can you just take us through the...
You don't always think of geothermal, but we also have hot springs here in the country. In the east of the country, I have two pictures here where we've got natural hot springs, water coming up at 50 degrees centigrade. And so when we were looking at clean and new energy sources, we thought, why don't we tap into this clean energy source that is just below our feet? On the left, you see a map of the UAE. It is quite densely populated, a lot of cities for the small size of the country. Most of the cities are located along the coast, and this is also where all our cooling demand is. Just to place into perspective as to what the demand for cooling is in the UAE, about 60% of our cooling consumption, of electricity consumption in the UAE goes primarily towards running HVAC systems and for cooling buildings, cooling industrial facilities, etc. So we've been looking very deeply into understanding what is the potential for cooling in this country and trying to tap into this very important clean energy resource that we have below our feet. In the next slide, you'll hear more about cooling in the UAE.
As my colleague mentioned, we are located in United Arab Emirates. We are located in one of the most demanding areas in the world for cooling. So the needing for a district cooling idea is very essential here. I will explain it here briefly. As you can see, there is a cooling plant here. And from this cooling plant, there is underground piping network feeding multi customers, This building could be an office. This building could be residential. This one could be educational or hospital. And these type of buildings are going to peak at different timing. This is the main idea about district cooling. For example, if office is going to peak from 8 to 5 or 4 p.m., residential from 4 or 5 p.m. till midnight, weekends. And instead of building a 10,000, for example, 10,000 ton for plant, build it for 8,000 with a diversity factor. So we can divide the load between buildings. So during the 2 years back, the saving by using the district cooling, it may be translated to 2.3 billion kilowatt hour. That is equal around, like energy is enough to give a power for 132,000 homes. And in terms of eliminating CO2, this equal to 1.3 million tons, which is also equal to remove from the streets 300,000 cars or more. So the idea of this cooling, as mentioned, to serve multi buildings at the same time. And Tabreed is one of the largest cooling companies in the world. We own and operate over 89 plants across 5 countries in the region. With our cooling capacity now is more than 1.3 million ton. To give you example for this number is more than enough to provide cooling for 100 towers at Burj Khalifa, which is the tallest tower in the world. And we are giving cooling for many areas in the region, like Burj Khalifa, like malls. Some of them are the largest malls in the world, the Metro of Dubai, some military places. So this is regarding district cooling idea.
Country that is quite heavily developed in our cities. So we need a clean energy source that has small surface footprint, and we need a clean energy source that can provide baseload power. Here comes in geothermal. We've been sort of studying the case for it. We have very strong ambitions for net zero by 2045. And we want to leverage this natural resource that is abundant over here. We also have one key advantage here in the UAE. We have been harnessing oil and gas for a long time. And because of that, we have expertise when it comes to drilling. We have expertise when it comes to operation of wells. We have expertise when it comes to dealing with water and transporting this water through large distributed networks. When we looked at the geothermal story for cooling, we realized we could identify about 30% less electricity consumption by using the heat instead of using electric chillers, which is the norm today in the UAE. A 30% reduction in electricity consumption has significant impact on the viability of the grid. It has significant impact on the ability to decarbonize hard to abate sectors, and it has a significant impact to also decarbonize the rural areas that we have. So what we then looked at is what are the different technologies that we may have in the geothermal space, what can we do with them, and how can we utilize them. Of course, you first have to start with understanding your subsurface. So we've undertaken detailed mapping exercises, trying to find the hotspots that there are, the depths at which these hotspots are. We looked at the reservoir systems, enhanced systems, natural systems. What are the new technologies that are coming out of the US, out of Europe, out of China, out of New Zealand? Looking at how we can couple them and utilize them in the UAE. We looked at specifically cooling technologies, so absorption coolers, adsorption coolers, but also other types of cooling technologies, what their efficiencies could be, how they would fit into the system here. And we also looked at power. Power in terms of binary power plants. We don't really have those dry steam options here in the UAE. It is not that hot. And we've looked at how we can go deep enough to leverage that power. Today in this talk, we will focus primarily on cooling, but we are also studying power in great detail with an exciting company out of the US, Sage Geosystems, that you all probably heard of. We have reached these milestones and conclusions and choices in our geothermal space because we've been conducting a lot of detailed feasibility studies over the last couple of years to really identify the ones that will help us in our region to get to where we are with harnessing geothermal in the energy mix.
So we're going to cover now the pilot specifically. So now we're going to come from this big picture, sort of like to narrow down more into what is that was done over the last few months in terms of scope, results, and timelines. So back to you.
The UAE has actually been very visionary when it comes to geothermal. The first geothermal wells that were drilled in the UAE were 12 years ago, 13 years ago in 2010. Two beautiful geothermal wells were drilled in Masdar city, which was developed as a world sustainable city. It runs off solar, it runs off wind, it runs off all renewable sources of energy. These geothermal wells were tested for very high flow rates, 100 liters a second, and produce water at more than 90 degrees centigrade. At that time, the district cooling network was just being built, and there were other technological challenges when it comes to the deliverability of the wells, the pumps, etc., that was still in a phase that needed to be developed. What we have done in the last few months is we've reopened the wells. We have checked for the quality of the wells, of the integrity of the wells. We've flown the wells again to confirm that the wells are in a state that is suitable to actually go. We've redeveloped the business case for it, and as we speak, we are implementing the surface facilities, as you see the building in the middle, to supply the district cooling network at Masdar City that is operated by Tabreed. This district cooling network at Masdar City is now supplying all the buildings that we have at Masdar City, and so we hope to tap into it and supply geothermal based cooling to this district city network. In the next slide, Ahmad will talk to you about the gains from this single pilot.
We decided to have this pilot where the wells are located. It is in Masdar City. As I mentioned before, like in UAE, we are mainly using the district cooling to provide cooling, and that has many benefits in terms of emissions, electricity efficiency. However, our chillers in our existing plants are electrical chillers, and here in UAE, electricity is being produced by the gas turbines mainly. So using a geothermal will have a further benefits to the district cooling, which we are currently using. For example, the current load in Masdar City now is almost around 6,000 RT, and the outcome cooling from this pilot is expected to be around 700 RT, which is around 10 to 12% from the cooling capacity of Masdar City. And in the efficiency side, as per our analysis, the efficiency is going to be around 0.4 kilowatt RT compared to 0.85 kilowatt RT by using the conventional district cooling system. This can be translated to eliminating 1.12 kilotons of CO2 a year. So you can imagine how this could be by implementing it to a larger scale after we finish this pilots.
Help us, please, with the timeline.
Scale of one well, we can already supply 10 to 12% of a single city that we're building here. So if you have a few more wells, we could really scale that up. What we are doing at the moment is this proof of concept at the pilot. If any of you are in the UAE, you have an open invitation to come and visit us and see the operation at the ground. But we are not stopping here. We are actively pursuing further sites. We're identifying further sites not only for residential space cooling and district cooling, but also cooling of industrial facilities where waste heat may not be available. Industrial facilities are significant in a highly industrialized economy as the UAE, and providing geothermal cooling would be another option. So we aim in the next 2 to 3 years to push this out at scale, first for district cooling, and then also to enable us to go for industrial cooling. However, we've already encountered challenges, and that's the next section that we will guide you through.
So geothermal, as we can see, is already an opportunity to decarbonize the use of energy within the UAE and worldwide. However, it comes with its own challenges, and one of the main challenges that already was faced during working on the geothermal is the cost of drilling. If you look at how we levelize the cost of cooling and we had to compare it to the current electrical systems that are used for cooling, we need to work on lowering the cost of drilling our wells. And for that, next, we tried to work on a fast pace and be agile, and we adopted a concept of having a drilling geothermal consortia, in which the objective was to drive the cost of these geothermal wells, including any social, environmental, and impacts that can be have, in addition to introducing new technologies to the field of geothermal, whether it's for power or for cooling as well. And the idea was to introduce the new technologies, field trials that has been done with our partners, including some of the companies that you already know, like Neighbors and Innovi in the US, and also to have an appropriate discussion and a continuous update on the emerging technologies of geothermal to help us drive the cost down. This consortia is an idea that it be continuous and work on quarterly basis, where we meet and try to find the solutions that will help us to make the geothermal case more impactful and more feasible for the community. Another challenge is the ESP.
We have been looking primarily into the business case for cooling. When we discuss the business case for cooling, the revenue that we will actually generate from this business case comes from the saving in the power consumption. What we have here is a comparison of the total power consumption for the current district cooling system with electric chillers on your left, and if you implemented a geothermal system with absorption cooling on the right. When you look chiller to chiller, that's the green bar, you see that's more than a 95% reduction or 90% reduction in chiller consumption between electric chillers and absorption chillers. So absorption chillers reduce the power significantly. This can be a significant cost saving. However, if you look at the total power consumption that is used in the system, it's not as impressive. It's between 20 and 40%. While this is significant in economies and in areas where electricity prices are relatively low, this makes the business case less and less economic. One of the biggest contributors to the power consumption for a geothermal system are the ESPs. That is the red bar that you see in this diagram. 30 to 50% of the power consumption is going towards running the ESPs. We need to find a way to have these pumps to lift the water, to get it to the surface, but by lowering the electricity consumption of the ESPs. This will make a significant impact on the business case. This will make the adoption and wide-scale use of geothermal energy for cooling a much more successful operation. So it's our call to any of the technology providers that are out there. If you are a technology provider out there and you have a solution that can significantly reduce the demand for ESPs, or you have another type of pump that can compete with ESPs and have much less electricity production, please call us. Now, leading from the ESPs, we have identified a rather significant challenge when it comes to materials. The picture on your left is the actual water that has been produced from the wells. They are highly saline, in fact hypersaline. They've got some nasty elements, trace elements of H2S or CO2. This causes issues with integrities for the casings, for the tubing, but also reduces the lifetime performance of the ESPs. The high flow rates also doesn't really help. What this has meant is we've had to spec our pilot with using materials like titanium, high quality chromes, alloys, etc. This leads to higher cost. So we are actually looking for material solutions for all elements of our system, ESPs, casings, tubings. What can we do such that we can retain the efficiencies, produce the hot water, get it to the surface effectively at the lowest power consumption while innovating on the materials? Can we use non-metallics? Are there any other smarter solutions out there? Can we get the cost down? Again, if you are a technology provider, this is an opportunity. Please call us. We really would like to work with you. Ahmad?
One of the challenges are here, the chillers. As I mentioned in our district cooling plant, we are using the centrifugal electrical chillers. When we come to the geothermal, we have to use absorption chillers or absorption chillers. In our case, we choose to have the absorption chiller. And comparing to the centrifugal chiller, we found the cost is almost 2 to 3 times, we can say 3 times than the electrical chillers that we are using. And this is the same for the weight. The weight is more than times the electrical chillers. The area, the footprint is almost 4 times. And regarding the cooling water or the makeup water requirements, it's double what we need than the centrifugal electrical chillers. So if anyone from the suppliers, from the chiller side, some solutions, some alternative ideas to use more savings, so please let us know and reach us.
Thank you very much, gentlemen. We came to the end of the presentation per se. We have some questions that come from the audience. Let me just throw one out there. This is something we have looked at, and I think it's a very good question. Can non-productive oil and gas wells that are declining in production be converted into geothermal heating wells?
Can I take that, Alvaro?
Yeah, go ahead, Rahul. Take it yourself.
Yes. So, yeah, that's an excellent idea. We have evaluated a couple thousand wells that we have across the UAE to identify its potential for geothermal. There are two aspects here. When we talk about geothermal for cooling, you would ideally want the source of energy to be very close to the point of consumption. And we don't have our wells in the middle of cities. So that eliminates some of that challenge for cooling. But for power, yeah, it could be an option. So we investigated that. One of the key challenges with using old oil and gas wells is the diameter of the wells that have been drilled. Geothermal wells require, or geothermal energy requires, large volumes of water to be produced to the surface. Oil and gas wells typically don't produce as high volumes of water on average compared to the fluid volumes that you need for geothermal. This means oil and gas wells have historically been drilled as smaller diameter wells. And when you have smaller diameter wells and you try to produce larger volumes of water, firstly, you reach technical limits for those. But also, when you have smaller diameter wells, you get frictional losses increase at higher flow rates. When frictional losses increase, you get larger sort of temperature losses. When you get larger temperature losses, you don't extract the same amount of energy that you have from the system. So if there are wells that meet certain diameter, like sort of minimum diameter ranges, they can certainly be looked at in more detail to convert them. But as a general trend, oil and gas wells tend to be drilled at as smaller diameter wells than what would be feasible for the geothermal application.
Thank you, Dr. Rahul. I have another question here that comes from the audience that is interesting. The question is how much of the UAE will be, I would probably say could be, reasonably cool with geothermal in the next, say, 10 years. So, Ahmad, pull your checkbook, sign and commit. No. Give us an idea of the order of magnitude of what is feasible, plausible, based on the findings on where we are right now.
As we discussed in our internal sessions during the selection of the chillers, the cooling towers, so we have to run this pilot for at least for one summer to check its durability and how far can we go by the geothermal energy to operate our chillers. So I can give an accurate answer after one summer, after operation our chiller.
That is a safe aspiration.
Could I take a stab at that, Alvaro?
Yep, go ahead.
Yes. So I think what we have done as a back of the envelope exercise, and Ahmad is really right. We just simply don't know, because geothermal, at least deep geothermal for cooling, is a nascent field globally. We don't really find a lot of people using 90-degree centigrade water for district cooling applications. We see a lot of shallow geothermal applications for cooling, but not really this deep geothermal applications for cooling. But if we had to put a figure to what we see as potential, we're talking the possibility of a couple of gigawatts worth of a cooling potential, if it all works out. There are big ifs, there are big ands, there are big technology hurdles to cross. But if you would like to know the size of the price, so to say, you can think of it in an equivalent of a couple of gigawatts of electricity consumption saved.
Thank you, Dr. Rahul. Another question is, what is the opportunity for the enhanced geothermal systems and or the closed loop advanced geothermal power or heat in the UAE? I guess this is obviously two architectures that we have studied quite deep, but who wants to take a shot at that?
Imad, you want to start, and I can come in after.
Yes, sure. So basically, this is something that we're already looking at currently, as Rahul mentioned during the presentation. We're working with Sage, we're evaluating old wells that are already existed, and we're trying to link that to the business case that we have been working on. We're trying to look at the feasibility of having these wells being producing power rather than looking at cooling at the moment, and it's a work in progress, and we're looking forward to the results maybe by the end of the year.
Thank you very much. Excellent. Another question, which also has to do with the CCS initiatives. There was a question here of the use of the CO2, has the use of the CO2 or for a thermal network cooling fluid been considered?
Ahmad?
I didn't get the question. Enter again.
Yeah, has the use of CO2 for a thermal network cooling fluid been considered? Injecting CO2 into for cooling?
No, we did no.
Okay, thank you. Okay, and then the other question that we have coming up here is, can the geothermal and the air capture and sequestration be combined in the UAE? I guess this concept of the integration of geothermal with carbon capture and solar with carbon capture and many things with carbon capture is becoming very popular. Rahul, you just came in from the World Geothermal Conference in China. Share good news about some of these use cases.
Yeah, so the short answer to that question is yes, absolutely. Technologically, it's feasible to add geothermal to the mix of CCS and enable that. But at the same time, it really depends on, let's say, the DAC technology, the site for sequestration, the availability of the aquifer resources for the cooling specifically. So yes, it's possible, but we have to, again, when we look at geothermal, we are looking at it holistically. from cooling, from power, but also as what it would do in the energy mix and how it would compare to the other renewable sources of energy. So the business case has to also be satisfied. And I think that is a very key element to be able to unlock this kind of integration. So geothermal plus plus is certainly a topic that can be utilized. It's certainly a topic that we are looking at, but it is going to be site specific and is going to be technology specific. Not all DAC technologies require a certain volume of cooling and heating. They might require it in different proportions, different quantities. Some of them, have the sort of capture cycles in certain frequencies that needs to be sort of understood in the context of the operability of the geothermal wells and their long-term impact. So there's a lot of things to study when it comes to integration of geothermal with other sources of decarbonization.
Yes, thank you, Dr. Rahul. And I can also add a comment on that one, is that within the entire decarbonization and clean energy plans that we're working on from the ADNOC perspective, we are putting our hands in all of these pieces. So we have got DAC running at the moment in the country at the piloting level. We are mineralizing CO2 in rocks already in another pilot. We're doing CO2 injection in aquifers. So all of these pieces of the equation are being rationalized to hopefully be integrated like the question suggests. So thanks for the question. Imad, I have a question for you before we run out of time. You had to run quite a bit fast during the execution of this pilot, getting pumps, getting equipment. Give us an idea of how you managed to get the logistics organized to come up in a period of 3 months to 4 months, something that had 2 years lead time. How do you manage to put a rabbit out of a hat with that?
Thank you, Alvaro, for the question. It was a bit challenging, but due to the urgency, we had to be innovative and we had to be problem solvers as engineers, all of us. So we needed to look for various solutions in the market and how we link it to our operation. So the challenge that we basically was the most area where we face difficulty is securing the wellheads for this well at that time. And as you all know, the lead time is very long for this item, that it takes sometimes 9 months to 1 year. And luckily we could find a certified worldwide by DMV, GL and Cameron wellhead manufacturer within the country that already agreed to support us and deliver the equipment on time for the pilot to be able to flow the wells in a very short period of time. Also, we did some integration basically between the operations within ADNOC itself, where we needed to work with different engineering teams, operation teams to give us the right support, to have the right equipment on time with the right operating procedures as well. And we needed, along all this, together with the career, to ensure that everything is done according to our code of 100% HSE practice, to ensure the safety of the operation, safety of the site, and the safety of the people that are on board on this site.
Excellent. Thanks, Imad. Yes, you certainly ran a lot. Ahmed, so we hear about collaboration here, of course. I mean, not only for the well evaluation point, but for entirely getting the business running. Give us a flavor of what has been the experience and the navigating through this collaboration from the Tabreed point of view, not only to achieve this pilot, but to grow the business going forward.
As you know, Tabreed is one of the leaders companies in providing district cooling, and also ADNOC is one of the leaders for oil and gas and geothermal drilling. So our both leaders, our companies, they agreed to have this project, and it went very fast and smooth, as you see. We just started mid of July, this project physically, and within like 1.5 months, we are going to finish it. So it was a great collaboration, and it was a good example for two national companies to deliver such a project.
Excellent, thank you. Yes, and there is another question here. that just came in about governmental support to ADNOC for this. Actually, I can take that. It's not just that. I mean, the economy of the UAE is all synchronized. It's an entire ecosystem of the industrial sector that is guided on certain fundamental principles that are supported by the government. So our projects on decarbonization, including geothermal and clean energy, involve very close collaboration with the UAE industrial ecosystem. We are talking about cement factories, aluminum plants, you name it, the academia, the investment community, obviously Tabreed and so forth. So we have a very active agenda as ADNOC and obviously Tabreed and so forth, with anything that have to do with achieving the country targets of reducing the emissions, both by 2030 and 2050, and the emissions of ADNOC by 2045. So there is priority to get all of these things going on. They are all ruled by business case. We have to be very careful to make things within the economic development of the business, and that is the priority that we have going forward.
I can
Let me Go
elaborate
ahead.
more
Go
on
ahead,
maybe
Imad.
on this, Alvaro, and just to highlight that UAE is doing this as a part of the strategy, that it's not now, but it's been going on through our late father, Sheikh Zayed, when he started the implementing the sustainability strategy and decarbonization across different sectors in the country, and the establishment of different sustainable decarbonization companies across UAE is not something new. It's just that we are pushing this journey forward through getting new initiatives and new innovative ideas that will help us reach our goals for decarbonization faster.
Thank you
So
very much.
to answer the question in short, yes, we get a lot of government support and a lot of support from across different entities to push this pilot through, but also to push all new energy sources through.
Excellent. Thank you very much. Let me
Alvaro, there
see
are a
if we
couple
got
of
any other
questions
final question.
regarding COP.
Yes. Go ahead. You want to take it, Ro?
Yeah, so yeah, if anyone is in the country during COP, we welcome you to come and visit our geothermal sites. We will talk about all our projects, not only this project, all the sustainability initiatives across the UAE will be showcased naturally over there. But also, it's a chance for us to engage, right? So it's not only about a project; it's about how we can build deeper collaborations with the world, how we can learn from you, how you can learn from us, and how we can scale this very important clean energy source across the country. There was a question I saw on the total number of wells that would be required if all of the UAE would be cooled with geothermal, and that's a very interesting question, because that number is in the thousands, right? So you can see the opportunity being there, even for a relatively small country in terms of population and area. It's significant. And to be able to scale that, all the actors in the ecosystem need to play their role and need to come together to be able to enable this. So we get a lot of support internally, we get a lot of support externally from our technology providers, and whoever is there that can support us further based on the challenges that we've portrayed today, you know where you can find us.
Thank you. So as you can see here, just to close, I can see here three key messages. The first one is the need for collaboration. Collaboration really made this happen and is going to be needed going forward across the industries, not just one company. The second one is integration. We got to consider all the opportunities to integrate what we do with geothermal with any other initiatives that will help the business case being more effective, being done faster, and being done much better. And then the third one is the infrastructure. As a country and as companies, we have to share our own infrastructure to support the whole thing. You're talking about access to sites, the subsurface, the facilities, the buildings, the highways, the electric grid. Everything of the infrastructure needs to be taken into consideration to really make all of this happen effectively. So with that, we want to thank all the audience who participated on this panel. I want to thank especially the organizers for having considered us being here, communicating this message, and obviously our colleagues who participated in this one. Anyone else have to say a solid thing before we say goodbye?
I agree with your points, Alvaro. You made it straight. We capitalize on the collaboration between everyone. This is the fast way to expedite this geothermal journey, and we look forward to working with everyone. Thank you all.
Thank you very much.
Geothermal everywhere.